senior design project for computer science this year was called Therapy Kinection. I'm Chris Walton. I'm the team lead as well as a general programmer.
I'm Davis Farish. I was the graphics and web designer, as well as one of the database programmers.
I'm Scott Grace, and I was the lead Kinect programmer, as well as the lead user interface programmer.
I am Kyle Sorantsev, and I was the documentation lead and testing lead.
I'm Christopher Witter. I was the lead database programmer, as well as the jack of all trades.
So tonight we're going to tell you a little bit about the origin and goals of our project, as well as what the Microsoft Kinect is, as well as the Vales For Test. We're also going to tell you a bit about our development environment and our system, tying everything together with a video demo. So at the beginning of last year, we wanted to work on a project that would utilize the Microsoft Kinect, and we also wanted to contribute to the healthcare industry as the department has done in the past. So we found therapists at Ben Hogan Sports Medicine that were interested in validating the grading of the Vales For Test. So we proposed a system using the Kinect to develop a cheap and simple system that would allow real-time automatic feedback and objective grading for the test. So the goal of our project is to objectively score the test, as well as to provide a tool for the grading of the Vales For Test, as well as validating the Kinect in the physical therapy field. We also want to create an inexpensive, user-friendly, and easily deployable system that would accomplish all of this. So the key part of our project was the Microsoft Kinect. It was developed by Microsoft for use on a Windows PC over just a standard USB port. And as you can see by this diagram up here in the top right, it is composed of a lot of sensors, including an IR emitter as well as an IR sensor, a microphone array that can help it localize sound in the environment, a video camera, as well as a tilt motor, and an accelerometer. Now the part that we were most interested in was the IR emitter and sensor, which allows the Kinect to track 20 joints on the human body, shown here. Now, whenever the programmer accesses these joints on the human body, they're presented as an XYZ coordinate, which, if you'll pretend that this is a Kinect, the Z-axis starts at the Kinect and gets larger as it goes out towards you. The Y-axis starts at the Kinect and gets larger as it goes up, and the X-axis starts at the Kinect and gets larger going to the left. Now, the main limitation we had when working with the Kinect is that it can only track the joints 30 times a second. And while that may sound slow, it's not so slow as to prohibit this project, because we may not be able to analyze fast motions like a baseball throw, but slow rehabilitative motions are perfectly suited for the Kinect. Now the Vales For Test is used by therapists to assess how far an athlete has recovered from an ACL or other leg injury, and if they're ready to return to their sport. It's composed of 4 components that are each designed to put stress on the injured leg. Currently, the grading is a little bit subjective because the therapists have to watch it and they can't be sitting right next to the patient taking measurements the whole time. And the grading, as we're told, is not yet an industry standard. Now, the components of the Vales For Test include the single leg squat, lateral bounding, forward jogging, and backward jogging. Each has a time limit that is divided into multiple segments and consists of 12 to 15 points. Now, the standards that a patient must adhere to during the test is they must avoid knee valgus, which we'll explain shortly. They also must avoid locking their knee and letting their knee go past their toe during the exercises. They must also have an adequate landing position and duration, as well as an upright trunk angle, and achieve a proper knee flexion angle. And now Scott and Chris Witter are going to tell you more details about the standards.
During the course of exercise, the patient must not have dynamic knee valgus. This means that during the course of exercise, when they're going down and doing their rep, their knee cannot fall to the midline of their body. We do this by analyzing the X position of the hip as well as the X position of the knee. If the X position of the knee falls midline or past the X coordinate of the hip, then our program sees that as being a knee valgus. And also, in order for a human to be able to pass this, we need to add a little bit of tolerance to the X value of the hip so that a human can do it, because you can't do it perfectly every time.
The second standard that we test is knee locking. It's not good for the patient to lock their knee during this test, and it was kind of difficult for us to test whether or not they got their knee locked, because for every single patient, their position that's considered knee locking is different. So what we ended up doing is, during our initialization phase, we took the Z coordinate of both the hip and the knee, and we found the difference between those two and used this as a baseline. And during our real-time analysis, we compared the current delta Z to the stored delta Z from the initialization phase, and if they were the same, we knew that they were locking their knee.
Another standard that the patient must avoid during the Vales For Test is their patella cannot extend past their toe. Now, while they're doing a rep, their knee is said to be past their toe when you see the patella fall past the front of the toe. Now, therapists see that as being, part of the front of the shoe, and the Kinect sees this as being part of the foot. And so, since we use by comparing the Z values of the knee and the foot, as when the Z value of the knee is less than the Z value of the foot, that means the knee is past the toe. Now, in order to allow for the difference in the Kinect versus what therapists see, we need to add a little bit of tolerance to the Z value of the foot because the Kinect is tracking using the ball of the foot rather than the end of the shoe. When we move this tolerance, we're able to offset that joint so that it is the same as what a therapist would see when they're grading it.
The next standards that we were testing were the landing position and duration. During these tests, when they were jumping back and forth and doing their jogging, we had to make sure that they were standing within boundaries set by the test. We also wanted to make sure that they were not landing for longer than 1 second, otherwise they were not putting enough stress on their injury to see if it was tested well enough. In order to make sure that they were not standing on their leg too long, we had to create a timer that started when their foot hit the ground and stopped when their foot left the ground. And then we made sure that was 1 second, and if it was not 1 second, we'd mark them on that.
Another standard that the patient must adhere to is they must have a proper trekking during the course of the exercise. And during this exercise, they cannot have a greater than 15-degree change from their baseline to the left or to the right, or 45-degree change from forward to backwards. And since not everybody stands at a perfect 90-degree angle, during the calibration phase, we need to get the baseline trunk angle so that we can have a baseline to measure from.
The last standard that we test is the knee flexion angle. And this is the angle right here that's created from a line in the top portion of the leg with the line from the bottom of the portion of the leg extending out past the knee right here. It's not the inside angle. And we verified our Kinect measurements with a goniometer, which is a instrument used by the therapist for specifically angles of this sort. However, we noticed that during our testing with the Kinect and using the goniometer that we weren't getting quite the same results between the two systems. And this made us realize that there was a difference between the joint that the Kinect was tracking and the joints that we were wanting to track for this test. And Scott will elaborate on this.
As Chris alluded to, the Kinect does in fact track a different type of joint than what the therapist would say is the joint for tracking the knee flexion angle. The Kinect uses what is called the anterior superior iliac spine, or ASIS, just a quick way of saying it. And therapists use the greater trochanter, which is located down here. Now, in order to change what we're looking at from what the Kinect sees to what we want to see what the therapists use, we need to get an X offset and a Y offset to change the coordinates to be what we want to see here. So in order to get those offsets, we get the X distance from the ASIS to iliac crest, and then we get the Y offset from the iliac crest to the greater trochanter. With these offsets, we're able to move the joint down there, and we store these measurements in the database for future use.
In order to get these calculations, we had to do some vector mathematics. Specifically for the knee flexion angle, to get theta 1, we found the supplementary angle of theta 2, which is the angle inside which was easily found. And so we subtracted theta 2 from 180, and we found theta 2 by creating vectors from the knee to the ankle, and then from the knee to the hip, and we used these mathematical formulas to find the angle.
I think it's very important and key into figuring out how exactly to know when the patient is actually doing the rep in the test. Because we needed to figure out a way to know when the patient's actually going down. And so in order to do this, we take a sampling of the Y value of the hip and analyze what's going on. So we're looking for a downward trend to signal the start of the rep. And once that downward trend turns to an upward trend, we know that the patient is at the bottom of the rep and they're at the point where their knee angle is going to be the greatest. And so at that point, we choose to start grading. And also we need to know what leg is currently on the ground so that we know that the leg we're grading is on the ground and not in the air, and is at the time that it should be graded.
The The scoring for this test was based on criteria provided by Dr. Craig Garrison. And their scoring particularly is if during one of the sections of the component, a person fails a standard 4 consecutive times, they do not get a point for that standard for that portion of the component. Also, if a patient does not meet the standard 9 times in any portion of that particular part of the component, they also fail that standard for that portion of the component. And to pass the test, a patient needs a total of 46 out of 54 points to pass. And this is a picture of our system. Basically, we have our patient right here who is being analyzed by the Kinect. The Kinect sends joint data back to our program, and our program analyzes the joint data to figure out whether or not they pass the test. And then they send that and patient results back and forth between the database for the users to see it and also just to store it. And this is the development systems that we used. For our primary support environments, we use Subversion and Tortoise SVN for our version control and to store our documents. And we also use Microsoft Office and some other programs to help us with our presentations and documentation. In particular, for creating our project, we used Microsoft Visual Studio 2010. We programmed in C# WPF application. We also use the Microsoft Developer Toolkit browser, version 1.6.0, and the Microsoft Kinect Studio, version 1.6.0. And our database was programmed using Microsoft SQL Server Compact Edition, and Davis will tell us more about our database.
Yeah, so this is a picture of our database schema. And the database is made up of multiple tables that stores data. For our database, we decided to split it up into 7 different tables. Shown here is only 4 of the tables because the other 3 components are pretty much the exact same as component 1 here. So at the top, we have the patient table, which is identified by its patient ID number, which is an automatically generated number. And then it has just the regular patient data, as well as the measurements that the therapist will take of the hip, also goes in the patient table. And then we have the injury table that is identified by both the PID and its injury number. And we created this table for a patient that has re-injured himself. He previously was in the clinic, came back, re-injured himself. And so when he comes back, he doesn't have to enter in all his patient data again. He just comes in, adds an injury, and it creates another injury insert that is connected to the patient table. We created the test table to store the test date, to know when the patient has started testing. Then we have the 4 component tables. This shares all 3 foreign keys that connects to all 3 of the previous tables. And in these component tables, we store whether they fail or pass each part of the component, as well as the total number of reps and points for each part, and of course the total score for each component. So this is a better diagram to help you guys visualize exactly how our tables interact with each other. Up in the top or left, we have the patient table, which has 1 or more injuries, and an injury needs 1 or more tests, and the test is connected to the 4 components, and these are of course the exercises like the single leg squat and the forward jogging. So now I'm going to show you guys a video demo. And for this first video, we're going to demonstrate exactly how our database works with the program. So we're going to go in here for the main window and add patient. We're going to enter in patient horned frog here. And all this data will be already available for the therapist prior to entering this. And the red boxes here are the boxes that are must be entered in. We're going to enter in the THR ID 1. So we're going to save and test this patient, which loads him into the main window here. And so we notice that we selected the left leg, and we actually want to test the right leg. So we're going to go in here to search patient. And we're going to search by his Texas Health Resources ID number, which is 1. And this brings up all the patients that where their THR ID starts with 1. And we're going to select our patient here, horned frog. We're going to go to update patient. So here in the update patient, we're going to change the involved involved side from left to right leg. Everything else here should be correct, so we're going to go ahead and update them. We're going to reselect him, and then we're going to hit the select button, which will load him into the main window, ready for testing. Now Kyle's going to show you guys a video of our test sequence.
Okay, so our patient is loaded, so now we can begin testing. I want to walk you through how the full test is done, and it's going to store the results in the database at the end of it. What you're going to see in this video here is Scott is going to show up in this corner so you can get the real-time footage of him, as well as you're going to see the Kinect skeleton show up here so you can get a comparison of how it looks. You're going to see that this image is mirrored. That's because normally the way we intended this is that the patient is looking at this image right here when they're performing the test. So it's like a mirror reflection. And then normally the patient would also be wearing resistance bands, making the test even harder than it is, but we figured we'd give Scott a break when we were filming this and make it a little easier on him. But he is now a master of this test, having done it at least 100 times. So first thing we do is we hit no on practice mode, so that way we're doing the full test. Once we hit select, Initialize Kinect becomes available. What this does is once we press Initialize Kinect, you're going to see a loading bar here. Once it's filling up, what it's doing is taking those important measurements that we talked about earlier. So it's going to take his knee lock angle, so he's standing here with his knee locked, and it's also going to get his forward trunk angle, because not everyone stands the same way when they're standing up. So that's how we fixed that issue. So now Scott is ready to begin, and we're going to hit Start Component. And then he's executing the test. So as he goes down, you're going to see each repetition here, and as well as what errors he's making. So right now we're seeing a lot of knee pass toe. So one of the ways we fix this is we can increase the tolerance, because our tolerance was too strict when he first started, and then you see it fixes the issue there. Okay, we skipped ahead. I didn't want you to watch the full 3 minutes of him performing the exercise. So now this is component number 2. This is lateral bounding. So once we hit start, Scott will begin execution. So one of the things he's doing here is his leg has to land outside of this red line. He has to stay inside this red line while he's performing this test. Also, the resistance band would normally be pulling him this way, right here. So he's performing this. He's making sure he sticks to all the standards, and the Kinect will pick up anything he does improperly. Okay, so we moved on to the third component. This is the forward jogging. Once again, we're going to hit start. This red line, he has to stand in front of this red line the whole time during the test, and the resistance band will be pulling him backwards from your point of view here. And once again, he's performing. So as I said, you can see that it's mirrored here, and that's because normally he would be looking at how he's doing. And then we skipped ahead now to the final component. This is the backwards jogging, very similar to the forwards jogging, except this time the resistance band is going to be pulling forward. So once we hit start component, the red line is drawn once again, and he has to stay in front of it while he's performing this exercise. And so I'm sure Scott's pretty tired by now here. Thick as calves, and just his whole legs just a lot more muscular than this. So TCU also keeps us in shape. And so now that it's done, we can hit stop test to end the test, and all the results are stored in the database. And once that is completed, the therapist now has the choice to either add a new patient, search another patient, or test Scott again if he really wants to go for seconds.
So now that the patient has finished his testing, we're going to go in here and look at some of his test results. We're going to go back to search patient. We're going to look them up by last name, our patient 1 project. And select them, and this time we're going to go to view patient. Here in the view patient window, here at the top, you can select which injury you want to look at for that patient, as well as at the bottom, you can select which test you want to look at. So down below here, it pulls up a tree view, which is expandable, and it shows all 4 components, as you can see, and each minute of the component. So for minute 1 here, he did pretty good, except for you see where he failed his knee pass toe standard. And here in component 4, minute 1, he did pretty good, so he passed all of his tests. So once the therapist is satisfied with his test results, he can has the option to export his patient data, which just sends a notepad file to the desktop. So now that the patient is complete, we're going to go back here, and we're going to make him inactive. So we're going to go to Update Patient. We're going to change his therapy complete to yes, and his status to inactive. And say he comes back 2 years later with another injury. Instead of creating a whole new patient form, you can just come in here and add injury. So we're going to enter in his new injury here. This time it's going to be the ACL. We're going to choose the same leg, the right leg, and the same doctor that did his surgery. So that injury has been added, and we're going to update the patient. And back here in the search window, you can see that his new injury with his ACL is the only one being showed. And if the therapist wants to see all of his old injuries, all of his old records, he can click the checkbox to show active and inactive injuries, research them, and everything will be pulled up there. So that concludes our video demos. Carl here is going to let you guys in on some technical challenges that we had.
Okay, so some of the challenges we faced when working on this project were, first off, we had to learn C# and Visual Studio 2010. So once we had the basics down, we then began looking into the Kinect. And what we found was outdated or limited Kinect documentation at the start. So we really had to just get in there and see what we could do with the knowledge we had. And I think we did a pretty good job at figuring that out. And then we did find some documents later on that really helped us out. And then some of the other conflicts or challenges that we ran into was merging conflicts with our SVN software. So basically we ruined a few documents while we were trying to merge them together. So we had to really learn what we were doing there. And then we had some limited database experience, but then we hit the books and made sure that our database was up to par to what you would see in the professional world. And then the Kinect. So we appreciate all the time the therapist spent helping us adjust the tolerances, because that was a really big issue with making sure the Kinect wasn't too strict when the therapist was when the patient was performing the test. And smoothing also. Originally we'd see hiccups in our Kinect, the data we were getting back from the Kinect, so we had to make sure we really smooth that data. And then, as they discussed earlier, we wrote the algorithms for rep detection, hip position, knee lock, and trunk angle. So some other challenges we faced. Scheduling and prioritizing. So we were a group of 5, so lots of people, with some people holding jobs, other people taking classes, so almost impossible to try to get everyone in, but we still had to do it. So we had to really time manage and make sure to keep everyone informed. We even had one person get married, Mr. Woodard here. He got married, and we told him, it's nice that he's getting married, but we needed this database stuff done today. He was a good sport about it. So. And then another issue we ran into is how to best utilize the skill set of our members. So we made sure to put the programmers where they needed to be, as well as the people who had more database experience on other issues. And Dr. Payne made sure we were always busy when we were working on this project. And then another issue was effective communication. So one of the things we did was we used an iPhone application, GroupMe, which sent text to everybody in the group whenever you would send that. And that really helped us out. So sometimes we'd wake up and see 50 text messages about some big issue that Scott or Chris fixed the night before, and I'd have to read through all that and try to figure out what's going on. But it helped us all stay on the same page, so that way we could all succeed in this project. And another issue or challenge that we had to make sure is that accountability amongst all our team members. So if you weren't getting your work done, there had to be repercussions for that. So it wasn't too bad. All the people did their work, so we didn't have to resort to any crazy measures. And then documentation, I think I personally, and I think most people would agree, we wrote more in this class than any English class. Maybe if I put all my English classes together, we wrote more documents in this class than any of those. And so we had to overcome that fear of writing and just document it all. But we knew the importance of it because we had the issues with the Kinect documentation. So results and future work. So our system provides real-time accurate feedback to the therapists while the test is being administered, and it also provides an objective way to grade the Vales For Test. The system also, what we saw, grades all standards simultaneously, which helps out the therapists as they are watching the standards. And the patients benefit because of this improved feedback while they're performing the exercise. And then testing, we found a high degree of success across a wide range of patients. So we had short people, tall people, all kinds of people going in through there and really stress testing our Kinect and software. And we really like how much success we saw there. So what's next in the future? So we're handing the system over to the therapists so they can potentially validate the Kinect in the physical therapy field, as well as see if there's any other possibilities in the future for the Kinect.
We'd also like to thank everybody who made this project possible, specifically the staff at THR Ben Hogan Sports Medicine, specifically Dr. Craig Garrison, Mike Macco, Joseph Hannon, Matthew Panucci, Gina Wolf, and Joelle Murrow. And we'd like to welcome them to provide any feedback they have on working with students for the past year.
Certainly. We have several former frogs that work at Ben Hogan Sports Medicine, and we're really excited to work with the students. Let me congratulate them on understanding a physical therapy test that was completely foreign to them. I think they did a great job and explained it really well. It was evident that they were trying to give us something that was of value and not just complete a project. And I think that we look forward to trying to validate this and use it in the future. So thanks, guys.
We'd also like to thank our senior design professor, Dr. Payne, for kicking us into gear every now and then. And also we'd like to thank Patrick Anderson from Microsoft, who donated the 2 Kinect units used during the development of this project. We have a few references right here. And we'd like to open the floor for any questions.
Don't be shy, I mean, we can answer anything.
You explained it too well.
Yes.
A lot of times when you're dealing with medical tests, people have to give you personal data that they might not want to be used for something else. They might not, I can't imagine on this one, but there might be something that they wouldn't want shared. Did you worry at all, or is that a next stage about security of the information in the system?
That was a concern at the beginning of the project, but that's why we opted for a database that's stored on the computer rather than in the cloud somewhere, because the computer that this would be running on would be certified by the THR IT department to meet HIPAA standards. And so as long as our program stayed on that computer only, we wouldn't have to worry about any further HIPAA regulations.
How difficult would it be to do another test, to do a different kind of a test that you wanted to take different measurements? How much of this would you have to go back and redo to do another test?
I mean, it would really depend on what kind of test it was. I mean, if it had some of the same, if it was all about, tracking joints, if you could find ways to be able to, use joint tracking measures and analyzing where coordinates are and doing positional type things, I mean, it's limitless as long as you need to track certain things, as long as it's not like, like a finger joint, because, I mean, there's not necessarily like a finger joint that the Kinect can use. It's more of the bigger joints. It's got to be something that involves the big 20 joints that the Kinect tracks. So like little things like that aren't currently possible. I think there are some things going on with the Kinect that are leading towards maybe the fingers being tracked, other little smaller things to maybe do different kinds of exercise. But really would just depend on what kind of an exercise it would be.
How long did it take to get comfortable with getting understanding of the tests so that you could actually implement your projects? It sounds like this was new for all of you.
We spent most of the fall semester learning to understand the Vales For Test, and even then in the spring semester we had a few hiccups where we had to get further clarification from the therapist over what a certain measurement was. For instance, knee valgus, we originally thought that just meant that your knee had to be centered over your toe, so we thought if it went outside your body or inside your body it was fine, but the measurement is actually only to the inside of your body.
What are you up against in terms of other products that may be already out there doing the same thing?
As far as products that exist that are doing this, I don't know of any, but I have read reports that Microsoft is actually working with the U.S. Army at the moment to allow for in-home rehabilitative motions for soldiers using the Kinect.
It's the same tool.
Yes, it's the same device. But as far as third parties, I have.
There's no any other in the market, any other medical equipment.
Nothing we've heard of. Haven't seen anything about that. We had to have a waiver of reference, and there's a couple, like a paper that's already kind of taken a look at doing some research with the Kinect to see if it was possible that a Kinect could be accurate enough to do, some kind of exercise for the sports rehab type of exercise.